Hello everyone, welcome back to Cybertix. So today is day 19 of TryHackMe Advent of Cyber. I hope all are you with me and following and understanding the walkthrough because these challenges are really awesome. We just got so many knowledge about different fields in cybersecurity. Where today topic is quite new and interesting, that is about memory forensic. Have you ever think about that there will be a field like this? I'll be waiting for your answer in the comment section. So let's get jump into our day 19 of task Advent of Cyber. So let's start with our day 19 challenge of the Try Hack Me, where today's scenario we will see about the elves are hard to work inside the Santa Security Operations Center, looking into more information about the insider threat while analyzing the network traffic log. MacBlue discovers some suspicious traffic coming from one of the Linux databases servers. Quick to act. Forensic MacBlue creates a memory dump of the Linux server along with a Linux profile in order to start investigations. So, today our learning objective is to understand what memory forensic is and how to use it in a digital forensic investigation. Understand what volatile data and memory data dumps are. Learn about volatility and how it can be used to analyze memory dumps. Learn about volatility profiles also. So we will clear out the basic understanding of this memory forensics, what are they and all. So what is memory forensics? Memory forensics is also known as volatile memory analysis or random access memory, that is RAM forensics. It is a branch of digital forensics. It involves the examinations and analysis of a computer's volatility memory to uncover digital evidence and artifacts related to computer security incidents, cyber crimes, and other forensic investigations. This differs from hard disk forensics, where all the files on the disk can be recovered and then can be studied. Memory forensics focuses on the programs that were running when the memory dumps are created. These types of data is volatile because it will be deleted when the computer is turned off. What is volatile data, by the way? In computer forensics, volatile data refers to the information that is temporarily stored in the computer memory, that is RAM, and can be easily lost or altered when the computer is powered off or restarted. Volatile data is crucial for digital investigations because it provides a snapshot of the computer states at that time of an incident. Any incident responder should be aware of that what volatile data is. The reason is that when looking into the device when that has been compromised, an initial recognized reaction might be to be turned on turn off for the devices that contains the threat. Some example of volatile data are running processes, network connections, and the RAM content. Volatile data is not returned to disk and it constantly changes in the memory. The issue here is what that any malware will be running in the memory, meaning that any network connections and running processes that spawn from the malware will be lost. Powering down the devices means valuable evidence will be destroyed. So, what do we mean by memory dump over here? So, a memory dump is a snapshot of the memory that has been captured to perform memory analysis. It will contain data relating to running processes captured when the memory dump was created. What are the benefits of the memory forensics? Memory forensics offers valuable benefits in the digital investigations by capturing real time data from the computer's volatile memory. It provides rapid insights into ongoing activities, detects stealth threats, capture volatile data like passwords, and allow investigators to understand user actions and system states during incidents, all without altering the target systems. In other words, memory forensics helps confirming malicious activities by analyzing a computer system's volatile memory to uncover evidence of unauthorized or malicious actions. Also, this is where memory analysis can be really helpful with the IR team, capturing the memory dump from any devices which will be much faster and smaller. Suppose we prioritize RAM over the hard disk image. In that case, IR team can already start analysis the memory dump of the IOC while being the process of capturing an image of the hard drive. So, what are processes over here? So, a process is an independent, self contained unit of execution within an operating system that consists of its own program code. data, memory space, and system resources. Imagine your computer as busy chef in the kitchen. The chef can cook multiple dishes simultaneously, but to keep things organized, they use separate cooking stations for different tasks. Each cooking station has its own ingredients, pots, and pans. These cooking stations represent what we call a processes in a computer. There is a category like user processes. These processes a user has started typically involves applications and the software users interact directly. Example, your Firefox browser, Chrome browser, any applications which we interact. Background processes. These processes that operates without direct user interactions. They often perform tasks that are essentially for the system's operations or for providing services to the user processes. That is about the example automated backups. Backups software often runs in the background, periodically backing up the data to ensure its safety and recoverability. So let's just connect with our machines. So as we had already connected with our machines over here, they had given the Ubuntu and password of the SSH. So let's just connect with our SSH. Note, if your browser is not copy paste, please use the split view connecting via the SSH and recommended. So let's just connect with our SSH. Now, let's learn about volatility. Volatility is a command line tool that lets digital forensics and incident response teams analyze a memory dump in order to perform memory analysis. Volatility is written in a Python language and it can be analyzed snapshot taken from the Linux, Mac operating systems, and Windows. Volatility has a wide range of use cases, including the following: just like list any active and closed network connections, list the devices running on processes at the time of captures, listing possible command line history values, extracting possible malicious process for further analysis, and the list will keep on going. So for this task, we'll examine the memory dump of a Linux device. For your convenience, volatility is already installed in our VM. So let's just take a look by entering the command of vol.py-h. So we will get a help command like that: volatility foundation, volatility framework, which is running on the version of 2.6.1, and they had given a help command. So at this time of writing, there are two versions of the volatility which they had given: volatility 2, which is built using in Python 2, and volatility 3, which is used in Python 3. There are many different test cases over here. We can also use it. Volatility profiles. Profiles are crucial for correct interpreting the memory dump for a target systems. A profile in volatility defines the operating system's architectures, versions, and various memories specific to the target system. So let's just use a hyphen info to get some information about the. So yeah, we got an information at the top. Yes, you can see there are so many processes which are running on, and these are the profiles, just like the Vista SP0x64, a profile for Windows Vista SP0x64 bit, and there are many informations which we can see it over here. Did you notice that there aren't any Linux profiles listed over here? It's all about the Windows only. Profiles for the Linux operating system has to be manually created for the same devices the memory dump is from. There are some reasons why we typically have to create our own Linux profile. Linux is not a single monolithic operating system, but rather a diverse ecosystem which has many distributions and configurations. So that's why we didn't create a profile over there. So creating a profile is out of scope for this room. So for your information, a profile is already there in this directory, that is the desktop slash evidence directory called Ubuntu slash this zip file. So let me just navigate to that thing. Now let's run a vol.py-info with the grep Ubuntu over here. So vol.py-info, and then we are grabbing the Ubuntu only, because we are already seen a Windows profile over here. So you can see that Ubuntu has been detected over here. Note, if you are curious about how to create Linux profile, you can find the given article by the TryHackMe or by the Nicholas Baguer, where it is very helpful. So now let's start with our memory analysis. The file linux.mem contains the memory dump of the Linux server. We are going to analyze this file. It is located in the home directory. For volatility, to begin the analysis, we have to specify the file -f flag and the profile with the hyphen hyphen profile flag. We can use and see using the hyphen h command, that is help command, to look all of different plugins which we can use in our analysis over here. Let's just copy the command directly from here. And we had got the same help command over here. So let's just understand what do we mean by volatility plugins. The history file is a good place to start because it allows us to see whether there are any commands executed by our malicious actor while they are being used on the systems. To examine the history file, we have to use a Linux bash plugins. So let's just use them. So let me just copy the command. So we can see that we are getting some outputs over here. So let's just wait for a few more minutes. And we can see over here that it is using a mysql-u root command where the password is about this random text. So let me just copy it, Control Shift C, and let's just solve the answer of today's question. What is the exposed password that we can find from the bash history output? So yeah, I guess this one. Yes. Let's get back to our main questions over here. While performing a cross-reference check with the ELF analyst who was thus using the server, we can identify using the suspicious commands which has given over here. You can type and perform the bash histories also to perform this check. Now that we understand what malicious actor has executed, we can look into the running system processes now. We have to use a Linux underscore ps list command. That is a Linux process list plugin it is. So let's just copy the command. So we had got the output over here. So let's just take a look into this, and we and just understand what is the minor process over here. So I guess this will also have some questions. Let's just take a look into the questions over here. What is the process ID of the minor process that we can find? Okay, so let's just get below. These are the already have zeros. So we had got the answer that is about the 10280 over here. So let me just copy that command and paste it. Yes. What is the MD5 hash of the minor processes over here? I guess we can't see. We have to perform another extract one. So let me just understand once again. Yeah. So process extractions. A good way to understand what a process is doing is by extracting the binary of the process. This will help us to analyze its behavior using malware analysis. We also want to extract the binary of the processes as a form of evidence preservation. To extract the binary of the process for examinations, we can utilize the Linux underscore proc_dump plugin. We can use it. And also there is a make directory extracted command. Then we can utilize -d flag to tell volatile where to place this particular extracted binary and indicate the process ID -p flag. So let me just perform the command. Let me just copy the command. So the command has been started and we will get the output of it. So let's just wait for a second. Here we got the output over here, and we can see the offset name, process ID, address, and the output also over here. So let me just copy that thing and paste it over here. So what is the MD5 hash? Okay, and then we have to navigate to another one which is about the Linux proc_dump, where we are adding the process ID that of 10291 over here. So let me just copy the command over here. Okay, we had got another hash over here. So let me just paste it over here. MySQL processes. Okay, use the command string minor with the process ID of the question 2 dot x04 and using the grep command. So whatever the answer will be, it will be our flag over here. So let's just understand and perform that. So about the cron job, right? So yeah, we have successfully extracted the suspicious program into the extracted folder. Having heard all about the commotions, 𝙁𝒐𝙤𝒏 offers to help the investigations by taking over the operations threat intelligence task. 𝙁𝒐𝒐𝙗 needs the MD5 hash to extract the binary, which can be provided using the following command. Okay, which we had already done. And then coming to the file extractions. So as stated above, we wanted to take a look at any cron job files that maybe has been placed by the malicious actor or the crypto miners. This can be help us to identify if there are any persistent mechanism to play. For example, in is the MySQL server process we can found before a part of the persistent mechanism. But how we can enumerate the files on the server? We can utilize it by using the plugin that is Linux enumerate files. So let me just copy the command. Cool. The service has been started and we had got the cron.services wherever the grep command which we had used over here. So let's just wait for a few more minutes over here. Cool. Now it has been completed. Now use the command over here of the services. So let me just remove that, copy that and paste it. Okay. We had got over here that is about a THM insufficient over here. So let me just paste that thing and okay. Now we have to define that using the Cyberchef. So let me just paste it like that. Okay. After reading the EL files, what location is the MySQL server dropped in the uh, or dropped on the file system? So over here we have to perform a cat extracted files EL. So let me just copy that. Cool. We had got the answer over here. So let me just copy the directory. Control Shift C, and then let's just solve the final answer. Cool. We had solved the today's questions of all the memory forensics, and I hope you enjoyed this task. Feel free to check out the volatility room of the TryHackMe. So I hope you get some insights of the memory forensics, as the level of this task was not for the beginners. But if you have any kind of queries, you can ask me in our Telegram community channel. So I see you in the next video. Till that time, goodbye and Jai Hind.